Today in Algebra 2, we start section 2.2, which begins / continues, I guess, looking at standard form of a quadratic function. And ultimately, by the end of both of these lessons, we want to be able to write and graph quadratic functions in standard form. To introduce day 1, we're going to look at Jordan and Emery's work. They both start with a quadratic in vertex form, and then they try to turn it into standard form. Now, we did this in 2.1, so I want you to pause the video and look at both of their work, and first decide, are either one or both of them correct, and why? And then also, why? Explain how you could prove that their equations are not equal to the original. Okay, so hopefully when you were looking at it, you noticed that neither one is correct. When we look at Jordan's work, you can see that he or she, I guess, accidentally distributed the two first, which is not the first step. Emery had the right idea and dealt with the binomial squared, but Emery made the common mistake of squaring the x and squaring the 4, but not expanding it fully. Okay? So the biggest thing is, how could you prove it? If you were going to do this, again, x minus 4 squared is like an x minus 4 times an x minus 4. You don't have to write it that way, but when you do expand that binomial, you should get x squared minus 8x plus 16. Okay, so that should have been the first step, and then you would do what Jordan did, distribute the 2 to all 3 of those pieces, and last but not least, you'd combine the like terms on the end. So again, that's a little bit of review from section 1 of this chapter, but we want to make sure that we do those steps in the right order. Having said that, this section is focusing on the form we switched it to, which is considered standard form. So let's now introduce again the standard form. So make sure you get in your notes that standard form is when it's of the form f of x equals ax squared plus bx plus c. And our goal is to be able to find the vertex of the quadratic function when we're given that. So in vertex form, we can actually just see it by thinking about the transformations. In standard form, you are not able to just look at it and pick numbers out of the function to be able to decide the vertex. So instead, to be able to find the vertex, which again is represented by hk of a quadratic in standard form, we actually need to use a couple of little math equations. First of all, you're going to find the h, so the x component. And the strategy we're going to use for that is to take opposite of b, or negative b, and divide it by 2 times a. Okay? So you'll take whatever the b is, take the opposite of it, and divide it by 2 times a. Now, if we think about what that means, if we ever have an x component of an ordered pair, which we will now once we find h, the way we can find the second value, or the k value, is by just plugging h back in. So that's how you're going to find k. You are going to substitute the value of h back into the equation for x and simplify. So again, the big thing you want to memorize probably is that h is negative b over 2a. It's not too big to think about. But then once you have that, you're going to plug it back into the equation to get the k. And that's how you're going to get your vertex. So let's do this example together. What is the vertex of the function f of x equals x squared minus 6x plus 10? And we know to find h, we need the a and the b value. So I always like to write down what they are. Now a, remember, it's the number attached to the front of the x squared. So there's actually not a number there. We need to remember that that means it's a 1. So a in this case is 1. B is the number attached to the x. And if it's minus like it is, it's a negative 6. Okay, so one common mistake is people would bring the x squared and the x over with it. Another common mistake would be that they would forget the negative with the 6. And once we know those values, we would do negative, so again, we're doing negative b over 2a. If we want to substitute, I bring down the negative. B is negative 6 over 2 times a is 1. Now, again, it's negative b. Sometimes people think about it as the opposite of whatever b is, because if b is a negative 6, a negative times a negative is positive. So I get 6 over 2, so my h is 3. So ultimately, when I go to write my ordered pair for my vertex, hk, the first value is going to be 3, which means that's my input. So that's where, again, we can just, to find k, we can do f of that value. So I'm going to do 3 squared minus 6 times 3 plus 10. And remember, function notation, this means plug that in for all the x's. Get 9 minus 18 plus 10. Negative 9 plus 10 gives me 1. Now, if you have your graphing calculator, you can just type all of this in one shot, or if you have a nicer calculator at all, it saves you the time of working it out by hand. But I do, in fact, get 1 for my k, so the vertex of this parabola is the point 3, 1. Okay, go ahead and pause the video. I want you to try this. I want you to find the vertex of the function f of x equals x squared minus 8x plus 5. Once you think you have it, unpause the video and check your answer. Here you see the work you should have had. Hopefully you identified that a was 1 again, but b was negative 8. A negative times a negative is positive. 8 over 2 was 4. When you plug 4 back into the original function, you should have gotten negative 11. So your vertex of this one should have been 4, negative 11. Go back and look. If you made any mistakes, try to figure out where you made that mistake. Otherwise, go back to the previous example and see how to do it again. Okay, so once we're able to find the vertex, now we take that and we use it to be able to graph a quadratic function in vertex form. This is mostly a 3-step process. You'll see that for the last one I put step 3 and 4, but I think of it as 1 step. So now we're going to figure out how to use key features to graph x squared minus 4x plus 8. And the first step is what we just learned. We are going to find the vertex. And we learned last chapter that that can also help us find the axis of symmetry. And we're going to find that as well, because that's going to help us graph. And we talked about this a little bit in the first section, so not a whole lot of this is new other than finding the vertex for step 1 anyways. So again, if I want to look at the example to find the vertex, again, my a is a 1, my b in this case is a negative 4, h would be an opposite of negative 4. So this time I'm just going to show it as positive 4 over 2 times a. 4 over 2 is 2. To find my k, I take that 2, I plug it back into the function. So we get to see another example of what we just learned. And again, I could type all of this into my graphing or scientific calculator at the same time. And when I type that in, I got 4. So the vertex is going to be the point 2, 4, which is the first thing we wanted to find. But then this one also said to find the axis of symmetry. And remember, we learned in section 1 that the axis of symmetry is the line that cuts the graph directly in half. So it's x equals whatever the x coordinate of the vertex is. So it's going to be x equals 2. Now, in order to graph a parabola, we need to find at least one other point. Historically, I've always liked to try to find 2 more points, so a total of 5. But in this section, they only require you to find 1 more. So the second step then is to find the y-intercept. It's always easy to find the y-intercept in standard form of a quadratic. So that's why we use that as our other key point versus making the table like we did when we were doing vertex form. Because in order to find the y-intercept, remember, that's when x equals 0. Which means I would take the function and I would plug in 0 for all my x's. But by default, remember, it's ax squared, so that's always going to be 0, minus bx, so that's times 0, plus 8. So if I'm doing ax squared, that's always going to be 0. B times 0 is always going to be 0. So when you find your y-intercept, it's actually always going to be equal to that c value. Okay, so you can go through and do the work. Otherwise, you can always just look at that constant on the end. So now I have the vertex and I have the y-intercept, so another point on the parabola. So I am now going to be able to graph it by plotting the vertex y-intercept And finally, the point symmetric to the y-intercept, because we know parabolas are symmetric. Okay, so now in this one, I don't have a grid on my screen, just like you won't in your paper, so I just sketch it in there. Again, I know my vertex is over 2, up 4. So I get that on my graph. You are allowed to, and remember sometimes Pearson has you draw in that line of symmetry, just as a visual. And then we found out that our other point we know is 0, 8. So 4, 5, 6, 7, 8. That's this point. Now the last thing I need is its point of symmetry. So that point was 2 to the left of the vertex. So now I need to go 2 to the right of the vertex and have it even with that. I do need to remember that parabolas are U's. So make sure when you do this, the reason I like to have 5 points typically with a parabola is because it forces us to draw the U shape. But again, we're only requiring 3 in this section, so you just need to make sure you draw it as a U, not as a V. Okay, so again, as a review, you find the vertex like we learned in the previous slides, and then that also will help you find the axis of symmetry, which we learned last section. A new thing on this slide is to find the y-intercept, but that's you plug in 0, so it's that C value. And then you graph it by plotting the vertex, plotting the y-intercept, and then reflecting the y-intercept over the axis of symmetry. And then again, be sure to draw it as a U. Okay, go ahead and pause it. And I want you then to try this one on your own. You're going to use the key features to graph the function f of x equals x squared minus 6x minus 1. So pause it and go through those steps. Find the vertex, find the axis of symmetry, find the y-intercept, and then graph. Okay, hopefully you took the time to go through that. Again, if you're not doing it on your own, you're not getting as good of learning out of it. But here's the work that I found. Actually, that was the wrong one. So I'm just going to go through it, I guess. Okay, so first I find my vertex. My A is 1, my B is negative 6. So opposite of 6 is positive 6 over 2 times 1. My H is going to be 3. For K, I'm going to plug it in. F of 3 is 3 squared minus 6 times 3 minus 1. When I type that into my calculator, I got a negative 10. So my vertex is 3, negative 10, which means my axis of symmetry is the vertical line, x equals 3. That's step 1. Step 2 is to find the y-intercept. Again, that's when x is 0. You might not have needed to do this work. You might have just seen that this was all going to go away. So you get 1, or negative 1, sorry. So it's the point 0, negative 1. So for step 3, I'm going to go to graph it. And again, when I go to graph it, my vertex is at 3, negative 10. So I go over 3, down 10. That's my vertex, which also represents my line of symmetry would cut right through that. My second thing I plot is my y-intercept, the point 0, negative 1. And then finally, that's 3 to the left of the line of symmetry. So now I go 3 to the right of the line of symmetry and put it at the same height. So those 3 points, as long as I am careful to draw a U through them, not a V, so I show that it's curved and kind of, oops, a little sloppy there. It should look like that. So sorry that I made you walk through that whole one. I just realized I copied the wrong slide on the next one. So that's what you should have gotten. Maybe not a bad idea for you to see me talk through it one more time. Okay, so that's the end of 2-2 day 1. So you should go now to your Pearson practice for the section 2-2 day 1 and see how you're understanding it.